Hello everyone, welcome back to my channel. I hope everyone is doing great. Let's solve today's LeetCode problem 757. Set intersection size at least 2. You are given a 2D integer array intervals where intervals of I is start of I and end of I, representing all integers from start till end inclusively. A containing set is an array nums where each interval from intervals has at least two integers in nums. For example, if the interval 1, 3, 3, 7, 8, 9, then these two are the containing sets. But we have to return the minimum possible size of the containing set. Okay, let's take an example. Okay, if you see, this is the containing set and each interval is containing at least two numbers from this set. Okay, the first interval contains 2 and 3. Okay, second interval contains 3 and 4, and the third interval contains 8 and 9. Okay, so this is the minimum possible set which can be formed such that at least two numbers from this will exist in each of its intervals. Okay, so generally whenever we are dealing with interval problems, it is most likely that we have to sort the intervals. Okay, so the given array, given intervals is not necessary to be sorted. Okay, so I just mentioned few things here. The question says minimize the numbers in the set such that each interval contains at least two numbers of it, right? That is what the problem statement says. So we know it's not necessary that the intervals which has been provided to us will always be in sorted order. Okay, it can be in any order. Okay, so we have to question ourselves that if the intervals are sorted, will there be any benefit that we will get? Okay, so just think about it. Okay, if intervals were already sorted, okay, so that means if we pick any two numbers from this particular interval, that means if both the sets are not overlapping, that means I should actually pick two more elements from the other set. Okay, so having intervals sorted will actually give us some benefit. Okay, but should we sort the intervals based on the start, or we should sort it based on the end of the interval? Okay, we have got the answer that we have to sort it, right? But how should we sort it? Should we sort it based on the start and on or how? Okay, if we sort based on the end intervals, okay, so let's in general talk about a few cases. Okay, let's have two intervals. Okay, so what are the common possible cases for two intervals? Both can be not overlapping, it can be partially overlapping like these two, or it can be completely overlapping, right? So whenever there is no overlapping, okay, that means we have to pick at least two numbers from these two intervals individually. If there's a partial overlapping, that means if you see here, the last number is actually overlapping. The end of the first interval is overlapping with the start of the second interval. So I can pick one number from this entire thing, and the common edge, and the one number from this. Okay, so total we can have to pick three over here. Here we can pick any one number from this particular range, and rest from other ranges we have to pick one. If there is complete overlapping, that means we have to only pick from in this range, so that it will contain in both the ranges, right? So if I pick one from this range and one from this range, then it's fine, right? So now the question arises, should we sort it based on ascending order of the start or ascending order of the end? Let's say if you observe, if we sort based on the end, okay, that means the smaller end values, intervals with a smaller end will always come in the initial stage, and the intervals with the higher end will come after it, right? So this is the interval with the smaller end, and this is the interval with the larger end. Okay, so our aim is to minimize the number of elements which we can pick from this interval, right, such that those numbers will also fall in the next interval or the subsequent intervals, right? So what numbers should we actually pick? If we pick the last two numbers, then it is most likely that these numbers will also fall in the next interval. Okay, here since there is no overlapping, that is the reason that we have to pick the next two numbers, two numbers from the next interval as well. But there is overlapping. That means if you pick the last two numbers, then it is most likely that the two numbers, one or two numbers, can present in the next interval. Okay, so that is the main agenda. Okay, so but okay, now that we understood that we have to sort based on the end, right? First we have to sort based on the end in the ascending order. But if both the end values, okay, if both the end values of a particular interval is actually same, okay, so let's take this example where both the intervals have the same end value. Now should I pick first this or should I pick first this? Okay, if you see, if you pick first this interval, that means the values, if you pick any two numbers from this, that means any two numbers, those two numbers will definitely lie in this interval, right? But if you pick this interval first, if you pick any two numbers in this range, it is not necessary those two numbers will always lie in the other interval. Okay, I hope you are understanding what I am trying to say. The if I pick an interval which has higher start value, then any two numbers which you pick from this interval will always lie in this interval. Okay, but if you pick an interval which has smaller start than another interval, that means if you pick any number in this range, okay, if you pick any number in this range, these numbers will not lie in the other interval. So we cannot 100% say any number you pick will always lie, but you can 100% say the numbers which you pick over here will always lie here. Since our intention is to minimize the count, okay, we will first try to pick the numbers from this so that the picked numbers will automatically fall in this interval as well, and we don't have to pick any extra number altogether. Okay, so that is the intention. Okay, so the bottom line is we have to sort the intervals based on the end of the interval first. If the end of intervals is same, then we have to sort based on the start of interval in descending order. Okay, so I hope you understood why it is descending order from this particular example. Yeah, let's say now that we have to identify the numbers which we have to pick as part of my result set. Okay, so let's say I have already identified, let's say I have already processed some intervals in num1 and num2. I have picked as a num1 and num2 were like end of this interval. Okay, let's say num1 now num2 is end of this interval and num1 is basically num2 minus 1. Okay, now since I have to basically check whether should I include two new numbers or these two numbers is already part of my next interval or not. Okay, so in order to do this check, okay, if my start, if it is greater than num2, that means num2 is not part of this interval. As a result, I have to pick two new numbers in my result set, right? So I will basically increment, in this case I will basically increment my answer by 2. Okay, because I have to pick two new numbers which will be part of my result set. Okay, the other case would be if it is not, if we are not falling in this case, that means num2 is not greater than num1. Num2 is not greater than the start of the next interval, right? Num2 is not greater than the start of the interval. Now I have to check whether num1 is greater than is less than start of the interval or not. Okay, here num1 is less than start of this interval. As a result, we are including two more new numbers in my answer. Now since num1 is not less than start of this interval, either it is equal to or greater than start of this interval in both these two cases. Now I have to check whether num2 is less than start of the interval or not. If it is less than start of the interval, that means only I have to consider one more new number as part of my solution. right? Because this num2 is contributing to one element in this interval. I need one more element which is part of this interval in order to satisfy my criteria, right? So I have to pick one more element from the next interval here, so that each interval will contain at least two elements from my set. Okay, so two num1 and num2 is coming from this interval, and I will pick one more number which is actually the end of this interval, which will be contributing to two elements in my result set, which will be num2 and num3 is coming from this particular interval, and num1 and num2 is coming from this interval. So the overall answer in this case would be 3. Okay, now let's say I have picked num1 and num2 from this interval, okay, which is num2 is basically the end and num1 is basically num2 minus 1. Here if you see, start of this next interval is not less than num2, it is not less than num1, okay. That means any two numbers, these two num1 and num2 which were picked in this interval will actually present in this interval as well. So I don't have to pick any new numbers as part of my result set, okay. So only these here I won't be incrementing any of my, I won't be including any numbers in my result set, okay. So these three are the possible cases for us to consider, okay. So let me jump back to my code and let me show you how I have implemented it, okay. As you can see, I hope my screen is visible. Let me zoom it out for you. So initially the idea is to identify the size of the containing set, okay. So I just defined a variable called size, which is 0, and initially my both the numbers will be minus 1, indicating that there is no interval before and both were minus 1, okay. Now as I mentioned, we have to sort our intervals based on the end values first, and if both the end values were same, then I have to compare based on the start of the interval in the descending order, okay. So my first comparator will be based on the end values of the interval, and if both were same, then I have to compare by the first element of the interval in the descending order. So I just mentioned in the reverse order, which will help me to basically sort the intervals in the desired format. Now that I have my intervals sorted in the required format, whenever I am processing a particular interval, I have to basically check the previous numbers which I have chosen so far, okay. So num2 and num1 were initially will be minus 1, and both minus 1s will be out of my range of my current interval. As a result, I will be including two elements into my result set, right? So here num2, which is minus 1, will be always less than start. As a result, I will include two elements into my result set. So what are those two elements? The two elements would be, the num2 would be the end of my result, and the new num1 will be end minus 1, okay. Now that if this condition is not satisfying, now that we have handled this case, now let's say it could fall in this criteria or it could fall in this criteria, okay. Now if num1 is less than start, okay, if num1 is less than start of the next interval, that means I have to include one more element in my result set, because num2 is already part of this interval. I should only include one more element. So my new num2 would be end of the current interval, and num1 will be equal to num2, okay. So this will be my num1 for this interval, and num2 would be this end of this interval, okay. And if both of these conditions were not satisfying, that means automatically my interval would lie in this combination, so I don't have to do anything, okay. And if you perform this entire calculation, the size would be our answer, final answer, okay. Let's try to submit the solution. As you can see, it is pretty efficient solution, and all the test cases were passed, okay. So before jumping into the analysis of time complexity and space complexity, I highly recommend you to subscribe to my channel so that you won't be missing any content I will be posting on daily basis. And yeah, let's jump back to the analysis, okay. So as you can see, we are just sorting our interval array, okay. So sorting would actually take a time complexity of n log n, right? And depending upon the algorithm it is using, the space complexity would be order of n, and yeah, time complexity is basically n log n, and the space complexity is basically big O of n, right? And this is just linear iteration which we are doing, which will be order of n. So overall time complexity for this algorithm would be the time complexity which is coming from the sorting algorithm. Okay, yeah, that's all about this problem. If you like the explanation, please do like and share your valuable feedback in the comment section. Thank you.